point 3, which is simplifying complex fractions. A complex fraction is a fraction within a fraction. In the first example, we have a fraction in the numerator, but just a rational expression in the denominator. That is still considered a complex fraction. In the second example, we have a fraction in the numerator and a fraction in the denominator, so that's a more complex fraction. So we're going to start with looking at complex fractions with numbers before we look at complex fractions with variables, with rational expressions. So some of you may remember the rule for dividing fractions. Remember this right here, this fraction bar means divide. When we divide fractions, we multiply by the reciprocal, but I'm going to go through the process of showing you why we multiply by the reciprocal. So what we want to do is get a 1 in the denominator, and I'm looking at this entire piece as our denominator. So in order to do that, I'm going to multiply the denominator by its reciprocal. And whatever you do to the denominator of a fraction, you do the same thing to the numerator. So in the denominator of my complex fraction, my 5's cancel and my 4's cancel, leaving me with 1 in the denominator. So when I look at the numerator, and I'm talking 2/3 as my numerator, I have now multiplied by the reciprocal of the denominator of the complex fraction. So then I simplify this, I don't see anything that I can cancel, any factors in the numerator and denominator, so I multiply straight across. 2 times 4 is 8, and 3 times 5 is 15. And if you cancel before you multiply, your final answer will be simplified, and it's easier to do that. But again, in this case, we didn't have anything to cancel. All right, so let's take a look at some complex rational expressions. So my first one, again, I've got that fraction in the denominator as well as the numerator. So I'm going to rewrite this as multiplication by the reciprocal. And I'm going to kind of shortcut it and just know that when I do that in the denominator, everything cancels. So in the numerator, I have 4 times 6 is 24. And in the denominator, I have x plus 2 squared, which I was going to write as a binomial squared, but I think I'm going to just go FOIL it out since I know there's no factors in the numerator that will simplify with that. So the x times x gives me x squared. I'm trying to change colors here. And I do this at the same time, so the x times 2 is 2x, plus another 2x is 4x, and then the 2 times 2 will give me a plus 4. So there's my final answer, and again, it's already in simplified form. My second example, same process. I'm just going to multiply by the reciprocal of the denominator. And since everything's already simplified and I don't see anything that I can cancel, I'm going to go ahead and distribute. So x times x is x squared. And then I've got 5x plus 2x is 7x. And 2 times 5 is 10. In the denominator, I've got x squared, negative 3x minus 1x is negative 4x, and negative 1 times negative 3 is positive 3. Jumping back up to the first example, one thing that I forgot to do was identify where the fraction is undefined, where the expression is undefined. Now in this case, we have a fraction within a fraction. So we have to look at this denominator as well as this denominator. Now in this case, my second denominator is never going to be undefined. It's 6. But my first denominator, the domain restriction is x plus 2 cannot equal 0. So subtracting 2 from both sides, x cannot equal 2. Sorry, my calibration's off. Let's rewrite that. X cannot equal negative 2. And that's what I would get if I were to factor this out, because remember, it came from here, the x plus 2 times x plus 2. So that's the only spot where this expression is undefined. So let's take a look at our second one. Again, looking at both our first denominator and our second denominator. And in this case, my third denominator. So I have 3 places where my expression is undefined. So x minus 1 cannot equal 0, x minus 3 cannot equal 0, and x plus 5 cannot equal 0. So adding 1 to both sides, adding 3 to both sides, and subtracting 5 from both sides. I have 3 values for which my original expression was undefined. 2 values for which my original expression was undefined. The third one came in when I created my final expression and simplified. So here and here was where my original expression was undefined. And this one came in when we simplified, and that became the denominator. All right, and our last one for this page. So again, simplifying this, I want to multiply by the reciprocal. But what I notice is that my first denominator is not simplified. So I'm going to simplify that first. I'm going to go ahead and flip that second denominator just to get that complex fraction out of the way. So again, that's a difference of squares. And then I'm going to multiply by x minus 1 over x. And I'm going to cancel everything that I can cancel. So in this case, I notice an x plus 1 and my x minus 1, which simplifies all the way to 1 over x. For domain restrictions, again, we have quite a bit to look at. So I'm going to look at the factored form, and before I canceled, I had x plus 1 in the denominator. I had x minus 1 in the denominator, which also was the denominator of my original denominator, so we've got that taken care of. And then when I flipped it, my x moved to the denominator as well. So I've got x cannot equal positive or negative 1 for my first two expressions, and x cannot equal 0 for my second equation. That is simplifying complex expressions. That's the new piece. This final slide is some review of adding and subtracting. So if you don't feel like you need this review, you can go ahead and stop the video. Otherwise, if you want to take a look at it, feel free to continue. So remember, when we're adding and subtracting fractions, we need a common denominator. So the first thing I notice about my first example is that second fraction, the denominator can be factored. So I'm going to do that first. I've got x plus 2, my first denominator. And my second denominator, once I factor, is x plus 2, x minus 2. All right, so I'm going to go ahead and multiply my first fraction by what's missing. And what's missing is x minus 2. So in the numerator, I want to distribute and simplify. So I get x squared from the x times x. And then I get negative 2x. And then minus 8 from my second numerator. Now remember, when you add and subtract fractions, you leave the denominator alone. I'm going to leave it in factored form, just in case I can factor my numerator and simplify this out at all. I'll distribute it later if it turns out I can't factor my numerator. So I'm going to think about what multiplies to negative 8 and adds to negative 2. So this is the T-chart method. I'm getting x plus 2, x minus 4. Sorry, let me fix that because my calibration is off. I was thinking a negative initially. So this is a positive sign. Sorry about that. All right, so my x plus 2's do cancel. So I can simplify this to x minus 4 over x minus 2. That's a great example of why you want to leave that denominator factored so that you don't multiply it out and then have to think backwards in order to simplify. So now looking at my domain restrictions, I'm going to remember that before I move on this time. I'm looking at my original denominators because once you find that common denominator, it came from your two original denominators. So really the easiest one to look at is this one because we changed our first denominator to match that. So we have x plus 2 cannot equal 0 and x minus 2 cannot equal 0. So x cannot equal positive or negative 2. There's our domain restriction. All right, and I'm actually, because now that I'm looking at this, I didn't have any examples that were negative. So I'm going to go ahead and change this to a minus sign. Actually, you know what? Sorry. I'm looking at that second one, and that's the one where you're more likely to make a mistake if it's subtraction. So I'm going to change that one. So this one, what I notice is my first denominator, again, can be factored. So what multiplies to negative 4 and adds to a positive 3, that would be an x plus 4, x minus 1. And I have an x plus 4 in my second denominator, so what's missing is my x minus 1. So I'm going to multiply numerator and denominator by that. Again, distributing in the numerator, leaving the denominator factored. So I've got x minus 3. And in the second numerator, when I distribute, I get 2x squared minus 2x, leaving my denominator factored. And then I'm going to combine like terms and try and factor in my numerator. So I get 2x squared minus x minus 3 over x plus 4x minus 1. So in the numerator, it's the AC method. So I'm thinking what multiplies to negative 6 and adds to negative x. I'm running out of room, so I'm going to factor that over here. Because this one we need to factor by grouping. Rewrite the middle term. What multiplies to negative 6 adds to negative x is a negative 3 and a positive 2. So I'm going to rewrite that middle term as a negative 3x and a positive 2x. And then I'm going to factor by grouping. So in my first two terms, I've got an x that I can factor out. And in my second two terms, I notice that already matches what I've got factored for my first term. So I'm just factoring out a 1. It's important to put that 1 there. Normally you don't write multiplication by 1, but when you're factoring by grouping, it's helpful to see that placeholder. So now my greatest common factor from both terms is 2x minus 3, leaving me with an x from the first term and a plus 1 from the second term. Now, when I compare what I just got here to my denominator, I see no common factors. So I'm just going to go ahead and leave it as 2x squared minus x minus 3 and distribute out that denominator, since I have nothing I can cancel. In my denominator, I get x squared minus x plus 4x is plus 3x minus 4. So the last piece then is looking at that domain restriction. So I want to, again, look at the factored form. And probably this one is the one that is easiest to read. So our domain restrictions are x plus 4. Let me rewrite that for you. X plus 4 cannot equal 0, and x minus 1 cannot equal 0. So x cannot equal negative 4 or a positive 1. All right, last review example. And again, I'm going to change this one to a subtraction because that's where we got a lot of mistakes. So what I notice is my denominators can both be factored. So I'm going to start with that. And I'm going to distribute that negative. I was already treating it as a positive sign. Sorry about that mess. Let's just start that one over. All right. So we've got negative 3x plus 2. So don't forget to distribute that negative sign through to both terms in your second expression in the numerator. Change it to a plus sign. It's much easier to keep track of addition than it is to keep track of subtraction. So factoring my denominator, I get 3x minus 1. So I have a common factor in each denominator. But I do have a piece missing. In the first one, I'm missing a 3. So I'm going to multiply by 3 over 3. And in the second one, I'm missing a 2. Make sure you distribute that 2 through everything in the numerator before you combine like terms. So in my numerator, I've got 3 times 3x, or 9x. In my second numerator, I've got negative 3x times 2, or negative 6x. And 2 times 2 is 4. And then in my denominator, remember, just look at one denominator because your denominator doesn't change when you're adding and subtracting fractions. So don't combine your denominators. So I'm just, going to take a look at this as my denominator. And the 3 times 2 is 6 times x minus 1. Because that's the same denominator in both fractions. I added them as I simplified the numerators. So I'm going to simplify the numerator further. 9x minus 6x is 3x plus 4, which is completely factored. And when I look at my denominator, which is completely factored, there's no common factors. So I'm going to go ahead and distribute that 6 to put it in standard form. And then talk about the domain restrictions. So we want to take a look at the factored form, which the easiest one to look at in this case is this one. 6 can never equal 0, so our only domain restriction comes from x minus 1. Adding 1 to both sides, x cannot equal 1 is our domain restriction. Alright, so that's review. Remember, quiz on Tuesday, there won't be a separate review, so there will be some spiral review in your homework assignment.